Video, we are continuing on a previous video. We're looking at a phet projectile motion simulation. We are now on page 2, and the latest direction on the phet simulation projectile motion document says to switch to the quote lab end quote tab. So at this point, I'm going to switch to the lab tab, and I'm wondering if I can switch this over. That doesn't work. I apologize. So we're now on the lab tab. I'm going to reload this. One thing of note, never change gravity or include air resistance on this when we're starting out. We're trying to learn this. Now step number 10 says to make sure your firing height is 0 meters. So we're at 0 meters. And observe a range when you fire. And so number 10, you're supposed to look through it and figure out your best angle. I will tell you it is not 25, 65, 30, or 60. There should be a different one that's the biggest angle. I'll let you figure out which one that one is. I think you can get that on your own. If we move on to number 11, again, this is something I would expect you to be able to do without much input. There's an equation for distance. One thing to note, that distance on here is called range. Horizontal distance is referred to as range on here. I want you to make sure that you notice that. Now, as we're getting into this, starts getting a little tricky. So I think I want to do an example here for you. If we look at number 14, it says that you were to drag this to a height of 10. Set your cannon to angle of 0. Launch speed to 15, and then to fire it. Now, I don't know if everybody saw this, but we can of course fire it. I was trying to make a note, maybe not everybody noticed. You can move this around, and this is important because we'll get to it later, but you can check right here to see if you're right or if you're wrong as far as your distances. On this one, you're just basically going to record it for number 14. Draw your picture, show what these distances are, and 14 should not have been too difficult. Where we're going to get to some tricky stuff is looking at step 15. Now, step 15 or number 15, hopefully you noticed that the instruction said to watch, complete it after you're watching a video. This is, of course, the video. And so number 15 is actually some notes I need to give you. You can put it on this paper and keep this paper in your notes. If you're keeping an organized area where you're keeping track of all your notes, I would highly recommend putting these there because this is something you're going to want to use and need for the upcoming days. This is also, these are the notes right here, and I'll explain in a moment, but this is glued to our wall back by where the 4 main acceleration equations are. But I want to point out, if you have a velocity, and that's represented right here by this arrow, and this is a V here for velocity, the y component of that velocity that we have drawn here, the y component, is equal to V times sine of theta, where theta is the angle off of the x-axis. So anytime you need to know the y component of a velocity, if you know the angle off of the horizon or off of the x-axis, it's the y component is equal to velocity times the sine of that angle, or we call it theta, off of the x-axis. Likewise, if you're curious about if you need to know the x component, the velocity x component, that's equal to v, which is this original velocity, multiplied by the cosine of that same angle, which is the angle off of the horizon or off of the x-axis. Now, if you go back to, I believe it was, I don't remember. If you go back to number 12 and also number 11, where it says it can be calculated using the x component of the projectile's velocity. If you look back to there, this is how you would find the velocity, the x component of that velocity. So now moving forwards, these are the two equations right here you want to make sure and have for number 15, and you also want to just have them in your notes in general. This is notes that you need to have. Just for your convenience, I have the trig functions over here in case you forgot about that. This is not really that relevant for the specifics. We could prove why this works. If you're curious, I can talk to you. But for all practical purposes, please just put this in your note.